Hi everyone, welcome to lesson 36. This lesson will be about equations of lines. We will not be graphing in this section. It will be more algebra based and we'll be focusing on equations. So we'll be writing equations of lines using some different formulas. Some of the formulas you've seen already. And right now we're about to see a new one. So what you're looking at right now on the screen is called point slope form. So this is one way to write a formula or equation of a line. And here's what it is. Y minus y1 equals m parentheses x minus x1. So what we'll see in this section is there's different reasons to use different formulas for equations of lines depending on the information that you're given. So this equation or formula called point slope form is useful if what we're reading right here, which says it's useful if you know the slope and a point. So in other words, use this form or formula if you know the slope and a point on your line, and your point would be labeled as x1, y1. Now, before we see an example of how to use this formula, I do want to very briefly show you how it's connected to another formula that we already know. So using our blank whiteboard screen here, I want to show you where this formula comes from. This is a little bit extra information, but sometimes it's good to know why we're doing something rather than just be handed a formula and not told why we're using it. So what I'm writing right now is the slope formula, which is what you've seen previously. M equals y2 minus y1 over x2 minus x1. This is a formula for finding the slope of a line. Now, if we adjust this just a little bit, if we rewrite it as m equals y minus y1 over x minus x1, that's a little bit of a different way of writing that formula. And when we don't have the little subscript numbers like the 1 or the 2, x and y kind of are just going to stand alone as variables. And when we leave them as variables, that's when we're not going to get just an exact number answer, but we'll get an equation for an entire line. So what I'm going to do next is basically rewrite this formula so it doesn't have a fraction in it anymore. You may or may not remember in a previous algebra class, you hopefully learned something about clearing fractions or canceling fractions. Basically what you can do is multiply both sides of an equation by the denominator of a fraction. So in this case, our denominator is x minus x1. If I just recognize that that's sort of its own expression in parentheses, what I can do is multiply both sides of my equation by x minus x1. So I'm going to do that. I'll rewrite it. Okay, so let's see. Just giving myself a little bit more space. So m equals, then giving some space, y minus y1 over x minus x1. Okay, so what I'm going to do here is multiply both sides of that equation by the denominator x minus x1. And remember with equations, whatever you do on one side, do to the other side to keep them balanced. If you multiply by the denominator, the x minus x1 will cancel out. And so what you're left with is, on the left side, what we now have is x minus x1 in parentheses times m. Well, if we rewrite that, that would be m parentheses x minus x1 equals, and then on the other side, what was in the numerator before is now just y minus y1. And it's not a fraction anymore. So we have m parentheses x minus x1 equals y minus y1. All we need to do now is just rewrite that so that the sides are switched. And then we'll see that this really does match up with what we were shown a few minutes ago, this formula called point slope form. So y minus y1 equals m parentheses x minus x1. Okay, it's possible that I just confused everybody. So if that is the case, then I'm sorry. You can let this go. This is a little bit of extra information. If you'd rather just see the formula and accept it for what it is, that's great. That's fine. I'm hoping at least maybe a few of you might appreciate seeing the connection between the slope formula, the m equals y2 minus y1 over x2 minus x1, being directly connected to this equation of a line, y minus y1 equals m parentheses x minus x1. Okay, and then we could take it even further and see the connection between this one and then slope-intercept form. So what we'll also see is we'll see more y equals mx plus b in this lesson as well. So bear with me for one more minute here. Y minus y1 equals m x minus x1. So hopefully, as you remember, if you're using the equation y equals mx plus b, 0b is your y-intercept. So if we plug in 0 for x1 and then b for y1, watch what happens. Now it's y minus b equals m parentheses x minus 0. Okay, well, let's rewrite that. X minus 0 is just x. So what we really have is y minus b equals m times x, or just mx. All you have to do now to rearrange it in yet another way is if you add b to both sides, now it's y equals mx plus b. Okay, so I told you we were doing a lot more algebra in this lesson. Again, a little bit of bonus for you. What you can take away from what we just saw over the past few minutes is just the three main formulas we're using in this lesson and in this unit. They're all connected. They're not just three random formulas coming from three different places. They're all different ways of expressing information about lines. Let's go back and let's actually practice using one of these formulas. So the first formula is point slope form. Y minus y1 equals m parentheses x minus x1. So once again, we're going to use this form if we know the slope, which is m, as well as a point on the line x1, y1. So here's our example. Write the equation of a line with slope 3/4 that passes through the point -5, 2. So every time you see the word slope, be prepared to plug something in for m. And we have one point, -5, 2. So I'm going to label the coordinates of that point as x1, y1. So now what we'll do is we're going to plug in some numbers for m as well as x1 and y1. X and y get left alone. And our final answer will be an equation of a line. Now, I didn't make it clear in the instructions here, but generally our final answer will be y equals mx plus b. We tend to want to end up with slope-intercept form by the time we're done. So we will be eventually solving for y. Okay, so let's plug in y minus, instead of y1, we're going to write 2, that's from the y coordinate of our point, equals, and then m is our slope. Now in the original problem we were told the slope is 3/4, so we'll write 3/4, and then parentheses x minus, now x1 was -5, so we will carefully write x minus -5. Okay, so this is an equation of a line. So technically we did follow the instructions, but on your homework, you'll be asked to write the final answer in slope-intercept form. So we have some more work to do. We need to eventually get our answer to be in this slope-intercept form, y equals mx plus b. So there's really about 2 steps. We're going to distribute that 3/4 to get rid of the parentheses, and then eventually we'll add 2 to both sides to isolate y. All right, and even before we distribute the 3/4, let's recognize that x minus -5 is really the same thing as x plus 5. So I'm just kind of making a big plus sign in there. All right, so now let's distribute the 3/4. 3/4 times x and then plus 3/4 times 5. Okay, so let's rewrite it. Y minus 2 equals 3/4 times x is 3/4 x plus 3/4 times 5. If you just put the 5 over 1 and then multiply straight across, you'll get 15, because 3 times 5 is 15, over 4 times 1 is 4. So we have y minus 2 equals 3/4 x plus 15/4. Our last step to get y by itself is to add 2 to both sides. So I'm just writing a little plus 2 on both sides. And then we'll need to simplify, which in this case means we're going to combine like terms. The 15/4 plus 2, we'll need to add that together. All right, so y equals 3/4 x plus, okay, so let's remember what to do with fractions here. 15/4 plus 2, if you put that 2 over 1, here I'll kind of bring my work up to this top corner. So 15/4 plus 2 over 1. If we get a common denominator of 4, multiply by 4 over 4, that's going to become 15/4 plus 8/4, which is 23/4. Okay, so our final answer, putting it all together, is y equals 3/4 x plus 23/4. Okay, good. Now, I told you we weren't going to be graphing, which is true, but what I am going to do in this lesson is I'm still going to show you what the graphs look like. You are not responsible for making the graphs right now, but it's sometimes nice to be able to see and verify what we just did. So I'm going to pause and take you to a graph of what we just did so you can see what it looks like to have a line with a slope of 3/4 passing through the point -5, 2. And we'll compare that to the equation. So I'm just pausing and I'll take you to that graph momentarily. Okay, so what we're seeing right now, I'm just using an online graphing calculator. The line that you're seeing is y equals 3/4 x plus 23/4. So that was the answer we just got for our equation of a line. What I've also labeled is this point -5, 2. And I just want you to see what it looks like. So let's see if we can find that. So -5, 2, let's see. Apparently it's labeled in purple here. Here it is. -5, 2 is this point here. And then in pink is this line that's been graphed. We can see it's going up from left to right. The slope is 3/4. So if we pick if we pick this point -5, 2 and we use the slope of 3/4, we would go up 3 and then over 4, 1, 2, 3, 4. So this is something you could graph by hand as well. You could start at that point -5, 2 and use the slope to extend your line. Now the y-intercept, apparently based on our answer, is 23/4. Now 23/4, what is that? Well, if you divide 23 by 4, that's 5 3/4. So on our graph, you can see this little dot right below 6, so somewhere between 5 and 6. And that's something that it would be more challenging to graph by hand. But if you start at -5, 2 and use the slope, you should be able to see that the y-intercept is somewhere between 5 and 6. But by using the equation that we did, we were able to get a more accurate answer of 23/4 or 5 3/4. So anyway, that's kind of the visual of what we just did. All right, let's go back. Okay, so we just did an example using point slope form, and we're going to be using other formulas as well. So let's take a look at our next slide here. And we'll see when do we use which formula. Okay, so what you see here is sort of some strategies for the remaining problems in this lesson, strategies for writing equations of lines. So on the left column, there's sort of a list of different scenarios. If you know blank, then do this blank. So in the left column, so here's some situations you might have. If you know slope and y-intercept, then plug into y equals mx plus b. So we'll see an example of that coming up. So that's kind of the easiest one. If you know the slope, you know m. If you know the y-intercept, then you know b, and that's it. Now what we just did in our previous example was we knew the slope and 1 point, but that 1 point was not the y-intercept. Remember how our point was -5, 2? The y-intercept has to have 0 for the x-coordinate. So -5, 2, it was just a random point on the line. It wasn't the y-intercept. So we were not able to plug in for b. Instead, we plugged in to the point slope form, and we used our coordinates of our point to plug in for x1, y1. So the situation we just did in our previous example, we knew the slope and 1 point, and we used point slope form. Y minus y1 equals m parentheses x minus x1. Okay, and then here are some other scenarios that are coming up if you know 2 points. Okay, if all you're given is 2 points, the first thing you need to do is find the slope. So to find the slope, that brings us to yet another formula, the slope formula. That's the m equals y2 minus y1 over x2 minus x1. In other words, that's rise over run. After you find that slope, then you can do what we did in our previous example. Then we can plug in 2-point slope form. So you can plug in for m with the slope that you just found, and then even though you're given 2 points, you can just pick one of them to plug in for x1, y1. What we'll see later on are some examples involving parallel or perpendicular lines. So here's our next scenario we might have. If you know 1 point and a line parallel to your line, what you'll do is find the slope of that line by solving for y. So if you solve for y, you're getting it into y equals mx plus b form. You can find m that way. Since parallel lines have the same slope, use the same value of m and yet again plug into point slope form. We'll see an example of this coming up. And then our last scenario that we might see, if you know 1 point and a line perpendicular to your line, here's what you can do. Find the slope of that line by solving for y, again, getting it into y equals mx plus b and identifying m that way. Then take the opposite reciprocal for your slope. So I want to just quickly remind us something you would have learned already about parallel and perpendicular lines. Parallel lines have equal slopes or the same slope. Perpendicular lines have opposite reciprocal slopes. So what does that mean? Well, for example, if one line has a slope of 5 over 4, then the other perpendicular line would have the opposite sign, so negative instead of positive, and then reciprocal means you're flipping the fraction. So if one line has a slope of 5 over 4, a perpendicular line would have a slope of -4 over 5. And then once again, you'd plug back into point slope form. So we're going to use that formula quite a bit. I'm going to briefly show us some graphs just to remind you and give you a little bit of a visual with parallel and perpendicular lines. So we're going to look at that graphing calculator one more time here. I typed these in ahead of time. What you're looking at right now, there's 4 lines on the screen, and then you can see the equations on the left side. So here are the equations that we're looking at. Y equals 2/3 x, y equals 2/3 x plus 5, y equals 2/3 x minus 3. Those are the first 3. So the 2/3 x, that's the mx part of your equation, y equals mx plus b. So these first 3 lines that are graphed all have the same slope of 2/3. So if you look at the graph itself, that's the purple line, the pink line, and the green line. I want you to see that they're all kind of going in the same direction. They have the same slope. They will never cross each other. They are parallel. Okay, now this 4th line, which is in blue, this one is y equals -3 over 2x plus 5. So the y-intercepts, I just kind of changed those up that's a little bit less important here. What I want you to really focus on is the slope. Okay, so this is an example of opposite reciprocal slopes. So the first three lines have slopes of 2/3. Those are all parallel. Whereas this other one, this blue one, this line has a slope of -3/2. So the 2/3 has been changed into -3/2. That's a perfect example of opposite reciprocals. And so this blue line is actually perpendicular to the other one. So it's crossing the other lines at a 90-degree or right angle. And I'm drawing a little square here, which is sometimes a symbol for perpendicular. Okay, so that's kind of a reminder visually about parallel and perpendicular lines so that you can maybe picture some of that when we're doing our various equations coming up. Okay, we'll get right back to our PowerPoint here in a moment. The last thing I'm going to share with you before we do that, I have, I'll plan to attach this so you can probably see it already with the video. I have this Word document here that's just titled Math 0931 Unit 3 Formulas to Memorize. So these are the three formulas we're using a lot in this unit. The slope formula, m equals y2 minus y1 over x2 minus x1, finding slope of a line given 2 points. Point slope form that we've just learned today, equation of a line given 1 point in the slope, y minus y1 equals m parentheses x minus x1. And then possibly the most familiar one, slope-intercept form, the equation of a line with slope m and y-intercept 0b, and that's y equals mx plus b. Okay, let's see. Also, what I have listed down here is just reminders about parallel and perpendicular. Parallel lines have equal slopes or same slopes. Perpendicular lines have opposite reciprocal slopes. For example, -1/2 and +2/1. So this is kind of a nice formula sheet to just have. I hope that you have some version of this just in your notes already, but I tried to just kind of put it all in one place. So these are the formulas and the information we'll be using quite a bit in this lesson. All right. Now let's get back. Okay, so we went through the slide about strategies for writing equations of lines. I think we need to do just a little bit more review with slopes, with parallel and perpendicular lines, and then we'll finally see some more examples writing equations of lines. Okay, so we have a little chart to fill out here. Slopes of parallel and perpendicular lines. So the left-hand column has equations of lines, and there's 4 of them. And then what we get to fill in is slopes. So we have one column for slope of a parallel line, and then we have another column for slope of a perpendicular line. So a few things we're going to keep in mind. If our equation is already in slope-intercept form, y equals mx plus b, then all we need to do is look at m to find the slope. So here's our first example. Y equals -4/11 x plus 5. Okay, so the slope of this line is -4/11 because that is the value of m in our equation. So that's the slope of this line, which means when we fill in our first sort of blank over here, the slope of a parallel line, that's going to be the same. Okay, so the slope of a parallel line would also be -4/11. Now moving on to the third column, the slope of a perpendicular line, that's where we get to opposite reciprocals. So if I take the opposite reciprocal of -4/11, the opposite sign would be changing from positive to negative, or negative to positive in this case. So instead of -4/11, I would have a positive slope. And then reciprocal, that means I'm going to flip the fraction. So instead of 4/11, I'm going to have 11/4. Now I've written a plus sign. That's not really necessary. You can just write 11/4. But I've written the plus sign just to be really clear that our slope is definitely positive. So just to recap for this first example, y equals -4/11 x plus 5. The slope of that line is -4/11. Therefore, the slope of a parallel line is also -4/11. And the slope of a perpendicular line would be positive 11/4. It's the opposite sign and reciprocal. Okay, let's go to our second example. The next equation is y equals 17. Okay, so does it feel like something's missing here? There's a couple ways to think about this. Y equals 0x plus 17 is one way to understand this equation. Okay, so this is a horizontal line. It is going side to side. So a quick little sketch over here. This line is going through the y-axis at 17. So it crosses the y-axis, but it does not cross the x-axis. Okay, so when we have a horizontal line like this that's going through the y-axis, the slope is 0. Therefore, the slope of a parallel line is also 0. But when we get to the slope of a perpendicular line, it doesn't quite make sense to take the opposite reciprocal of 0. And if we try to do that, I guess if we imagine the 0 being over 1, it would then be negative 1 over 0. That's not really a number. Anything over 0 is actually undefined. So the true answer for the slope of a perpendicular line would actually be undefined. And just a reminder, when you have a horizontal line, a perpendicular line to that would be vertical. So possibly if you're writing on lined paper right now, all those blue lines going from the left to the right of your paper, those are all parallel horizontal lines. And then that red line going up and down on the side of your notebook, that's vertical. And that red and blue, those lines are perpendicular to each other. Or you can just look at this chart that we're doing, right? We have these horizontal lines, those are parallel, they have a slope of 0, and then vertical. Those slopes would be undefined. So just to recap for this one, our equation was y equals 17. That line goes through the y-axis at 17, it's horizontal, so the slope is 0, therefore the slope of a parallel line is also 0, and the slope of a perpendicular line would be undefined. Let's move to our third example, 8x minus y equals 2. Okay, so this equation does have x and y. Let's rearrange it and solve for y. So I'm going to start by subtracting 8x on both sides. So then we have negative y equals negative 8x plus 2. I'm trying to get this equation into slope-intercept form, y equals mx plus b. The last thing I would do is divide everything by negative 1 to get that y by itself. When I do that, if I divide everything by negative 1, all your signs are going to change. So instead of negative y, now I have positive y. Instead of negative 8, I now have positive 8x, and then instead of plus 2, I now have minus 2. So my new equation would be y equals 8x minus 2. If we compare that to y equals mx plus b, 8 is m, so our slope is 8. So that means the slope of a parallel line would also be 8, because parallel lines have equal slopes. Which brings us to perpendicular lines. If our original line has a slope of 8, and a parallel line would have a slope of 8, the slope of a perpendicular line would be the opposite reciprocal. So the opposite of positive 8 would be negative, and then the reciprocal, if I imagine this 8 is actually 8 over 1, I would need to take the reciprocal of 8 over 1, and that would turn into 1 over 8. Okay, so we started with 8x minus y equals 2. We solved for y and got y equals 8x minus 2. Our slope was 8. The slope of a parallel line was also 8. The slope of a perpendicular line would be negative 1 over 8. So that's the opposite reciprocal of 8. Okay, one more row to fill out in this chart here. Our last equation is x equals 13. So let's see if we can compare this to the equation we did above with the y equals 17. X equals 13. Okay, so this line will actually be going through the x-axis at 13. This is a vertical line. I can't even try to write it in slope-intercept form, y equals mx plus b, because there is no y in the equation, so that's not even possible. The slope of a vertical line is undefined. So if you have an equation like this, x equals 13 or x equals a number, It's a vertical line going up and down, crossing through the x-axis. The slope is undefined, which means the slope of a parallel line would also be undefined. And that brings us to the last question, the slope of a perpendicular line. Well, if I have a vertical line, a perpendicular line would just be horizontal. And remember, the slope of a horizontal line is 0. So take a look at 2 rows above in our little chart here. They both have 0 and undefined, just kind of in those opposite spaces. So our last example that we just did, the equation was x equals 13. That represents a vertical line going through the x-axis. Vertical lines have undefined slope. So a parallel line would also be vertical, and that slope would also be undefined. A perpendicular line would be horizontal, and then that slope would be 0. Okay, so I tried to cover a lot in that one slide. We practiced solving for y. We practiced looking at y equals mx plus b to identify slope. Hopefully we got a good recap of slopes of parallel lines being equal, and then slopes of perpendicular lines having opposite reciprocals. And we also got a little review of horizontal lines and vertical lines as well. So lots going on there. Feel free to pause and just make sure you got it all down. Then we're going to move right along and we'll practice writing equations of lines. Okay. So we're now in kind of our next little section of our notes here. The directions for the next few problems will be the same. It will say, write the equation of a line with given characteristics in slope-intercept form. So that means every one of our answers will end up in y equals mx plus b form. But each problem will be different in how we start it. So here's number 1. Here are the given characteristics. So here's the information we're given. Slope 5, y-intercept 0, 9. Okay, so what does that mean? Well, the slope of our line is 5, so that means m is 5. So we're not quite sure what equation we're plugging into yet, but whatever it is, we can replace m with 5. And then we're given the y-intercept in this case. So we are given b. Our y-intercept 0, 9, that means b equals 9. So this is kind of the easiest of the examples. We don't really need to do much work other than just plugging in to y equals mx plus b. So we can get straight to our answer. So our answer is y equals, instead of m, we will write 5, and then x plus, instead of b, we'll write 9, and that's it. So y equals 5x plus 9. Now, if you did plug into point slope form instead, which is what we're going to do for the next few examples, here's what would happen. It would still work out. You'd do y minus y1 equals m parentheses x minus x1. Your x1, y1 would just be that 0, 9. So x1, y1. So x1 would be 0, y1 would be 9. So you'd write y minus 9 equals 5, because remember we're replacing m with 5, parentheses x minus 0. And then, I mean, normally we distribute at this time, so I guess you can do that. 5 times x is 5x, and then 5 times 0 is just 0. So you'd write plus 0. So y minus 9 equals 5x plus 0. Just add 9 to both sides. Y equals 5x plus 9. So that's a longer way to get there, but it would still work out. So you can always start with point slope form. But I hope you see that if you're given the slope and the y-intercept, you're good to go. You can just fill in that y equals mx plus b right away. Okay, that was number 1. Number 2, we don't have the same information. This time we're given 2 points. So the information for number 2, it says contains the points 15, 2 and 0, -3. So this is one of those times when we're given 2 points. And so what we need to do first is we need to find the slope. Okay, how do we find the slope? Okay, there's a formula for that. M equals y2 minus y1 over x2 minus x1. Okay, so I'm going to label our coordinates up here. So 15, 2, I'll just label that as x1, y1, and then 0, negative 3, we'll label that as x2, y2. It doesn't really matter which point is which, I just kind of go in order. And now we'll carefully plug in. So m equals y2 minus y1, that would be negative 3 minus 2 over, and then in the denominator, x2 minus x1, that would be 0 minus 15. Now let's simplify. Negative 3 minus 2 is negative 5. 0 minus 15 is negative 15. So we have negative 5 over negative 15. This can be reduced. Negative divided by negative is positive. We'll reduce by dividing by 5 as well. So it becomes positive 1 over 3. That is our slope. That is not the full answer because, as you can hopefully remember or you wrote down before, our instructions on the previous slide said write the equation of a line. Not just find the slope, but write the equation of a line with given characteristics in slope-intercept form. So we have the slope, but we don't have the equation of our line yet. Okay, now for this problem, notice that one of our points actually has 0 as an x coordinate. So we are actually given the y-intercept here. 0, negative 3 is the y-intercept. So we actually do have B. Now that will not always be the case. So I'm going to pretend I didn't know that. And what I'm going to do is I'm still going to plug into point slope form, but we'll come back to that little piece of information a little bit later, and we'll see, what would be a different approach we could have taken. But for most of the problems you'll see like this, you will have to use point slope form. Okay, so let's do that. Y minus y1 equals m parentheses x minus x1. Okay, so that's going to be y minus 2, I'm looking at what I labeled up here, equals m, now we found m was 1/3, so 1/3, and then parentheses x minus our x1 was 15. Now the formula has x1 and y1 in it. You can use x2 and y2 instead. All that matters is you're plugging in coordinates of a point on the line. It doesn't really matter which point. So now I'm going to keep going. So we have y minus 2 equals 1/3 parentheses x minus 15. The next thing we would do is distribute the 1/3. All right, so then we'd have 1/3 x minus, and then 1/3 times 15 would be 5. So 1/3 times 15 over 1, it's 15 over 3, which reduces to 5. So on the right side of my equation, we would have 1/3 x minus 5. Still on the left side, we have y minus 2. So y minus 2 equals 1/3 x minus 5. The last step to get y by itself is just to add 2 to both sides. So y equals 1/3 x, and then negative 5 plus 2 is negative 3. All right, so we did it. So here's our final answer, y equals 1/3 x minus 3. Now, I want to go back to the observation we made earlier about this point 0, negative 3. We kind of already knew what B was. So a slightly shorter way of doing this would be after you find M, after you find the slope, you can take that 1/3 and plug it in for M, and then you would just take negative 3 and plug it in for B. So you could just go straight to the y equals mx plus b equation. Y equals mx plus b. But I purposely did it the longer way because sometimes we just have to. There will be, most of the problems you'll see, you will not be given B. So you won't be able to just immediately plug in for B. You'll have to go through the point slope form. All right, good. Now, I think what I'm going to do is pause again and show you the graph again. I'm going to use that graphing calculator I've been using today. So I'm pausing, and then I want to show you what this graph looks like. Okay, here we are looking at the line whose equation we just found. So what you're looking at right now, this sort of pink line is y equals 1/3 x minus 3. That was the answer that we found before. And what I've labeled on this graph as well are the 2 points that we were given. So 0, -3, that's down here on the y-axis. And then 15, 2, that's over here. So 15 to the right and then 2 up. I just wanted you to see that both of those points were on this line. And then here's the equation, y equals 1/3 x minus 3. Okay, so another way to do this, if you're not using a formula, I guess another thing you could do is just plot both of those points. Here, let's try that. So I'm just showing you, like, look, it works, but here's another way you can do it. On your own graph paper, here we'll use a better color, you could just plot those 2 points, 0, -3, and then 15, 2, and then you can connect them in a line and then find the slope. Now, in this case, one of the points that you're given is the y-intercept. That's that 0, -3. And if you connect these in a line, here's what you would get. Let's try it. I'm doing this by hand now. I mean, it's a little harder to find the slope without the formula, but you could find it sort of by counting between your 2 points, right? So between the 2 points I was given, 0, -3, and 15, 2, let's see, I would be going up 1, 2, 3, 4, 5. So up 5 and then over 15. So our slope would be 5/15 or 1/3. And then you could write y equals, instead of m, you'd write 1/3 x. And then our b, our y-intercept, was that -3. So y equals 1/3 x minus 3. Anyway, just a different approach you can take, or just a visual way to kind of check your answer. So it is still important to be able to plug into the formulas that you're seeing today, but I'm trying to show you some alternatives. I realize I'm showing you an online graphing calculator, which maybe that's surprising. Am I showing you how to cheat? I don't think so. I think I'm just showing you how to kind of verify your answers and visually see what it is that we're doing. So, all right, let's go back. Okay, so we did number 2. It looks like we have a couple more related to parallel and perpendicular lines. So number 3, this time we're writing an equation that passes through 5, 6, that's a point, and is perpendicular to 2x minus 4y equals 9. All right, so let me take us back a few slides to remind us, how are we supposed to do this? So earlier in the notes, we had this chart that said strategies for writing equations of lines. This is actually the last one in that chart, or in that table. We have 1 point and a line perpendicular to your line. So what do we do? It says find the slope of that line by solving for y. Okay, so I think that's what we need to do first. Get y by itself so we can figure out what m is. Then we'll be taking the opposite reciprocal for our slope. Okay, so that's kind of giving us a little idea of how to start. Okay, so again, passing through 5, 6, I'm going to go ahead and label those coordinates x1, y1. And then perpendicular to 2x minus 4y equals 9. Okay, that's the equation we need to solve for y. In other words, we need to get it into y equals mx plus b form so that we can find m. So let's work on solving for y. I would start by subtracting 2x on both sides. So 2x minus 4y equals 9. Let's subtract 2x on both sides. So then we'd have -4y equals -2x plus 9. And then our last step to solve for y, we would divide everything by -4. Y equals -2x over -4. The -2 over -4 would reduce to +1/2. So y equals +1/2x, and then plus, we'll just call this -9/4. I don't really care about that y-intercept right now. I just really need to focus on the slope, because the whole point of that step in solving for y is to figuring out what the slope of that line is. So the slope of this line, y equals 1/2 x plus -9/4, the slope is the 1/2. That's the slope of this line. But we don't want to use that slope. We want our line to be perpendicular. So we're going to take this value of m and we're going to take the opposite reciprocal. The opposite reciprocal of positive 1/2 is now going to be negative 2/1. In other words, our new m, our new slope, is actually going to be -2. So here's what we've done so far. All of that work was to figure out our value of m. It was to figure out our slope for our line. Okay, so we started with that equation 2x minus 4y equals 9. We worked on solving for y. We got y equals 1/2 x plus -9/4. The 1/2 was the slope of that line, but our slope needed to be the opposite reciprocal because we are trying to write an equation perpendicular to this line. The opposite reciprocal of 1/2 is -2/1. In other words, it's -2. Okay, so now what we get to do is we get to use point slope form. We have our point 5, 6, and we have our slope -2. Okay, so I've taken us to a new screen here. So we have our slope -2, we have our point 5, 6, we labeled that x1, y1. We're now going to plug into point slope form. So y minus y1 equals x, or excuse me, equals m parentheses x minus x1. And now we're going to plug in. M will get replaced with -2. x1 will get replaced with 5. And then y1 will get replaced with 6. So let's see if we can keep that all straight. Here we go. So y minus 6 equals -2 parentheses x minus 5. Okay, good. We're only a couple steps away. Now we're going to distribute and then we'll be solving for y and we'll finally have our equation. So here we go. Let's distribute our -2 to get rid of those parentheses. So here's our new equation, or our next step. So it's y minus 6 equals, and then as we're distributing the -2, we now get -2x, and then -2 times -5 is +10. Our very last step will be to add 6 to both sides to get the y by itself. So then it's y equals -2x plus 16. Okay, very good. One more time, I'm going to pause and show you this graph. Okay, so we're looking at our graphing calculator now. What I have right now is a point plotted, 5, 6, and then I have this line 2x minus 4y equals 9. And I'm just double checking something here. Yeah, okay, so that's what we started out with in this problem, and we were trying to write the equation of a line that passed through or contains the point 5, 6 and was perpendicular. So I'm going to, by hand, sketch what I think that would look like. Okay, so I'm going through this point 5, 6. I want to try to make a line that's perpendicular to this green line that we see. And that's a hard thing to sketch by hand. But that's kind of the main idea, okay? So I'm trying to draw, not quite, I'm trying to draw a line that's going through the point 5, 6, and that's perpendicular to 2x minus 4y equals 9. That's sort of my sketch. Now let's clear that. What I want to do now is just sort of do a visual check of the answer that we got. Okay, the answer that we got was y equals -2x, and I'll just stop right here. Look at my line that's already being graphed. This is just y equals -2x. It is perpendicular to that green line, okay? So therefore 5, 6. So we need to kind of shift the line up, and that's why this wasn't our answer. Our answer was y equals negative 2x plus 16. And now you can see the line has shifted. It's still perpendicular, but now you can see that 0.56 is on the line. Okay, so again, what I'm showing you, this isn't solving the problem, it's more just visualizing what we just found to be true. Okay. I think we have one more to do. The problem we just did was number 3 about passing through a point and being perpendicular to another line. And our last example, number 4, has to do with being parallel. Okay, so our last example, we're writing the equation of a line that contains the point 2, 9 and is parallel to x plus 6y equals 5. Okay, I think I am going to take us to that graphing calculator to kind of do a little brainstorming, and then we'll use the formula. Okay, so let's go take a look there. All right, so this time our line is passing through or containing the point 2, 9. So I'm just going to get that graphed over here, 2, 9. And this time we are parallel to x plus 6y equals 5. Okay, so at least visually I'm trying to picture what we're looking for. I'll just do a rough sketch here. Parallel means it's not going to cross, so these lines will have the same slope. I haven't found the slope of this line yet, so that's something I'll need to do. And this is what it will look like. I'll try to sketch a parallel line that's passing through this point 2, 9. Okay, and I'm just kind of sketching on the screen here. That wasn't very good. And you can see this is why we need those formulas, okay? So you're not just kind of eyeballing it. But this is giving us a general idea of what we would expect. Man, this is not working. All right. There you go. That's about as good as I'm going to do. Okay. So it looks like the y-intercept is somewhere between 9 and 10. Our slope will be the same as the slope of the green line. Now maybe I can find the slope of the green line. It looks like it's given me the y-intercept, so we're going down 1 over 5. So it looks like our slope is going to be negative 1/5. And now we need to do some work to figure out what the y-intercept is. We'll need to go back and use the point slope form, but it looks like whatever our y-intercept is, it's going to be a fraction. So we're getting ready for some fractions here, and that's okay. All right. Okay, so when we're dealing with parallel or perpendicular lines, we do need to remember some information about slopes. Parallel lines have equal slopes. So whatever the slope of this first line is, that's the slope we want as well. But I don't know the slope. I kind of just found it from the graph. Negative 1/5 is what I think it is based on my counting on the graph. But let's figure it out from the equation. So let's take this equation, x plus 6y equals 5. Let's solve for y. So we'll subtract x on both sides. So that's 6y equals negative x plus 5. Oh yeah, see, I was wrong when I counted. I counted wrong, as we're about to see. I thought the slope was negative 1/5, but look what it's about to be. If we divide everything by 6, y equals, instead of negative x over 6, I'm going to write negative 1/6x plus 5/6. Okay, so looks like I was close, but not totally accurate with my slope, but that's why we have equations, so we can be more accurate. So our slope is negative 1/6. And since we're dealing with parallel lines, we want to keep this same slope. So we will use the slope of negative 1/6. All right, now we have our slope. We also have our point because our line contains the point 2, 9, that's x1, y1. So now what we can do is plug into point slope form. So y minus y1 equals m parentheses x minus x1. So let's start plugging in. Y minus 9 equals, what we got for m was negative 1/6. and then parentheses x minus 2. All right, so now we'll start simplifying. I'm going to need to distribute that fraction. Negative 1/6 is being distributed. So on the right side, we'll have negative 1/6 x. Negative times negative is positive. If I multiply 1/6 times 2 over 1, that would be 2 over 6, which just reduces to 1 over 3. So I'm going to write plus 1/3. So our full equation right now is y minus 9 equals negative 1/6 x plus 1/3. My next step to solve for y is to add 9 to both sides. So I'm writing plus 9. I'll write plus 9 over 1. I'm going to need to add the 1/3 plus 9 over 1. Let's get a common denominator of 3. So that becomes 27 over 3. So I'm really adding 1 over 3 plus 27 over 3, which will be 28 over 3. So y equals negative 1/6 x plus 28 over 3. That's our equation. All right. Let's go check it in our graphing calculator and see if it actually does what we expected. Okay, so we're back to the graphing calculator. I'm looking for a line that passes through 2, 9 and is parallel to this green line, this x plus 6y equals 5. Now, I mistakenly thought I was finding the slope, but when I zoom in, I was not accurate with the y-intercept. I just kind of eyeballed it and I thought the y-intercept was 1, but it's not, it's 5, 6. Okay, my eyes couldn't tell that. So I was wrong about the slope. What we found algebraically is our slope is actually negative 1/6. All right. So all we're doing right now, I'm just going to type in the equation that we got and see if it is parallel to the green line and then passing through the point that we wanted. Now, I just want to show you, remember how I thought the slope was negative 1/5 by accident? Let me just show you what that looks like. See, it's close. So what I just typed in is y equals negative 1/5 x. There's a blue line now next to the green line. They kind of look like they're parallel, sort of, but if we zoom out enough, we'll see that they're not. They do eventually cross. So the slopes are close, but in order to be parallel, those slopes have to be exactly the same. So I was wrong before about the slope. Let's type in our actual answer. So what we got is y equals negative 1/6 x. There's the parallel line, okay? And then our y-intercept plus, remember we thought it was between 9 and 10, so let's see if that's still true. What we got is y equals negative 1/6 x plus 28 over 3. There it is, okay. So what we're seeing right now is we're seeing these two parallel lines. They both have a slope of negative 1/6. And the line that we just graphed does go through the point 2, 9. And our y-intercept is 0.28 thirds. Now 28 thirds, that's 9 1/3. Okay, so remember we thought it was between 9 and 10. We were right, but we couldn't really tell what that fraction was just by looking at the graph. So that's why we needed the equation, and we got 28 thirds for the y-intercept. Okay, so what you're looking at again is two lines that are parallel. Our line is passing through this point 2, 9 and is parallel to the original line. Okay, good. So we've made it through our examples in our notes. And the last thing I'll remind you about is our list of formulas. I showed you this before. Just keep coming back to these. These are the formulas that we're using in this unit, the slope formula, point slope form, and slope-intercept form, and then here's that reminder about parallel and perpendicular lines. All right, so that was lesson 36, and after this there's 2 more to go. Lessons 37 and 38 will still be graphing lines, but we'll be actually graphing more than one line at a time, and we'll be talking about systems of equations. So we'll be graphing 2 lines and seeing where they cross. So that's kind of what's coming up. And then lesson 38, We're graphing inequalities, so that means we're graphing a line and then shading on one side or the other. So we're getting there. I feel like once we get past this lesson 36, this is a big one. So you're so close. We're getting there. Let me know if you have any questions as always, and keep up the good work. Thank you.